Radio waves are a type of electromagnetic radiation with wavelengths in the electromagnetic spectrum longer than infrared light. Radio waves have frequencies from 300 GHz to as low as 3 kHz, and corresponding wavelengths ranging from 1 mm to 100 km. Like all other electromagnetic waves, they travel at the speed of light. Naturally occurring radio waves are made by lightning, or by astronomical objects. Artificially generated radio waves are used for fixed and mobile radio communication, broadcasting, radar and other navigation systems, communications satellites, computer networks and innumerable other applications. Radio waves are generated by radio transmitters and received by radio receivers. Different frequencies of radio waves have different propagation characteristics in the Earth's atmosphere. Long waves can diffract around obstacles, like mountains, and follow the contour of the Earth. Shorter waves can reflect off the ionosphere and return to Earth beyond the horizon, while much shorter wavelengths bend or diffract very little and travel on a line of sight, so their propagation distances are limited to the visual horizon. To prevent interference between different users, the artificial generation and use of radio waves is strictly regulated by law, coordinated by an international body called the International Telecommunications Union. The radio spectrum is divided into a number of radio bands on the basis of frequency, allocated to different uses. Discovery and utilization. Radio waves were first predicted by mathematical work done in 1867 by Scottish mathematical physicist James Clerk Maxwell. Maxwell noticed wave-like properties of light and similarities in electrical and magnetic observations. His mathematical theory, now called Maxwell's equations, described light waves and radio waves as waves of electromagnetism that travel in space, radiated by a charged particle as it undergoes acceleration. In 1887, Heinrich Hertz demonstrated the reality of Maxwell's electromagnetic waves by experimentally generating radio waves in his laboratory, showing that they exhibited the same wave properties as light. Standing waves, refraction, diffraction, and polarization. Radio waves were first used for communication in the mid-1890s by Guglielmo Marconi, who developed the first practical radio transmitters and receivers. Propagation. The study of electromagnetic phenomena such as reflection, refraction, polarization, diffraction, and absorption is of critical importance in the study of how radio waves move in free space and over the surface of the Earth. Different frequencies experience different combinations of these phenomena in the Earth's atmosphere, making certain radio bands more useful for specific purposes than others. Speed, wavelength and frequency. Radio waves travel at the speed of light. When passing through an object, they are slowed according to that object's permeability and permittivity. The wavelength is the distance from one peak of the wave's electric field to the next, and is inversely proportional to the frequency of the wave. The distance a radio wave travels in 1 second, in a vacuum, is 299,792,458 meters, which is the wavelength of a 1 Hz radio signal. A 1 MHz radio signal has a wavelength of 299.8 meters. Radio communication. In order to receive radio signals, for instance from AM/FM radio stations, a radio antenna must be used. However, since the antenna will pick up thousands of radio signals at a time, a radio tuner is necessary to tune in a particular signal. This is typically done via a resonator. The resonator is configured to resonate at a particular frequency, allowing the tuner to amplify sine waves at that radio frequency and ignore other sine waves. Usually, either the inductor or the capacitor of the resonator is adjustable, allowing the user to change the frequency at which it resonates.